Now, we're going to also look at optimizing cylinders because these are the two most used shapes in the industry. And when we are dealing with cylinders, the optimal dimension always occurs when the height is twice the radius in your shape. Okay, so when you have your circle, right? In order for you to optimize that cylinder, your height should be exactly the same as diameter or as twice as your radius. Okay, so in this case, what is the surface area of, if you go back, what's the surface area of the cylinder? What's the formula for it? 2 pi r squared. 2 pi r squared. Plus 2 pi r h. And then what's the volume? What's the volume of the cylinder? Okay. Now if you look at this, both the surface area and the volume, they have both the radius and the height in the formula. When I want to optimize, I don't want to have two unknowns. And I know that h is equal to 2r, right? So what I can do, because this is the shape that is going to give me the optimal volume and the optimal surface area. So what I can do is, I can replace the h's in the formulas with what? 2r. Because h is equal to r for me to be able to optimize. So when I do that, if you look right here, everything will be only with respect to r. So the only two unknowns that I have, well, one of them is going to be known, but it will be the surface area and the radius. So what happens here is by me substituting 2r in for h, I get this. 2 pi r squared plus 2 pi r times 2r. Okay, so I replace the h with 2r because I know that's going to give me my optimal value. Now let's simplify this. If I simplify this, it's going to be 2 pi r squared plus 2 times 2, that's 4 pi r squared. You guys agree with me? Yeah? 2 times 2 is 4, pi, r times r is r squared. Now if you look at this, I have 2 pi r squared plus 4 pi r squared. Can I simplify this? What is it? 6 pi r squared, right? So now, if you look at this, my surface area is only dependent on the radius, right? I don't have too many variables. I only have the radius as my variable, right? So I can solve. Otherwise, I won't be able to solve if I have too many variables. Now I can do the same thing. I can replace that h with 2r to find the volume of the specific shape cylinder. That's going to give me the optimal. So pi r squared, 2r instead of the h. So that's going to give me 2 pi r cubed. So when I'm optimizing cylinders, I don't use my regular formulas that are in my formula sheet, right? If you want to use them, you have to be careful to change your h into 2r, so you can use these two formulas. Okay? Similar idea to what I did with the cube, right? Where they either give me the surface area or they give me the volume, and I have to look for the dimensions, okay, that optimize my shape. So in this case, I have the surface area of a can of soup is 154.6 centimeters squared. Find the optimal dimensions of the can. Here's where is my keyword to know that I have to use the optimized formulas. What formula do I start with? The surface area formula, which is 6 pi r squared. So instead of surface area, I'm going to replace that with 154.6. Now the question is, how do I isolate for R? What do I do? I divide 154.6 by 6 pi. You have to be careful that when you do that on the calculator, if you're going to do it all together, when you put the division, you're going to have to put 6 times pi in brackets to give you the correct answer. Okay? And then you have to square root. Right? So R is when I square root, after that, I'm going to get R equals, sorry, that looks like a V, 2.86 centimeter. So in this case, my radius is 2.86, and then I have to state what my height is, because for a cylinder, I need radius and I need height. I know that the height is equivalent to twice the radius, so it's going to be 2 times 2.86, which is 5.72 centimeter. Therefore, the radius of the optimized cylinder is 2.86, and the height is 5.72. You're not getting the answer? Divided by, open bracket. And there. You don't need to do second.
Oh.
Yeah. Divided by 6 times close bracket. I'll square root that. Now, if I ask you, what is the volume of this cylinder? What do you do? So if I'm adding a question to this, and I'm asking you, what is the volume of this cylinder? Then I have to use the volume, right, which is volume equals 2 times pi times r cubed. Instead of r, I'm going to replace it with 2.86, right, and find my answer. Okay? Are you guys okay with the whole idea of it? Okay? Knowing what formula to start with, knowing how to isolate, these are the important parts of this lesson. Okay, the volume of a Pringles container is 1800 centimeter cube. Find the optimal dimension of the container. So what formula do I start with? 2 pi r cubed. Yep. Because I'm given the volume, right? So to find the radius, I have to plug in 1800 for the volume. And what do I do to isolate? Divide by 2 pi. And then and then cube. That's right. So on the calculator, you're going to just do, again, 1800 divided by bracket 2 times pi. If you don't put the bracket, it will divide by 2, but then it will multiply by pi, so it will be wrong. And then you're going to do the cube root. And your radius should be 6.6. Okay. And since I know the radius, now I would know my height, which is 2 times the radius. And then you're going to write your therefore statement.